Welcome back with a brand new video, and in this video we discussed about the edge triggered D flip-flop. As you can see here, basically these are the combinations of three SR flip-flops. So simply we have to memorize this circuitry only, and we have to draw this circuitry three times. Now what's happened here only the thing that the Q, you have to memorize the upper NAND gates always gives us output as a Q. You can see this one is Q1, you can say this one is Q2, and this one is a Q. Okay, now what's happening here? Let's go. First of all, here we have the input as high, which comes in a NAND gate, and this output is shared by the bow is becoming the input of both circuitry, which this NAND gate similar as the SR flip-flop and also becoming the input of this NAND gate. Why we are using the in also as the inputs of this mm, flip-flop circuitry? Because we have not any other input or any other circuits in edge triggered D flip-flop. So edge triggered basically is triggered, you can say, is due to the clock signals, that why, and edge is the name of this flip-flop circuitry. And if you will see, if I make this input as low, you will see here that we will get high at a Q slash. You can see here the waveforms that as I make the D input, this one is D input as low, the Q becomes low. And if I make this circuitry as input as high, the Q becomes high. Here we have a some time gap that is due to the circuitry. But if we, you can say, if I speed up the circuitry, you can easily understand. Let me slow down the a little bit too for your understanding of you. You can see here a little bit. Yes, you can now easily understand that what is happening here. If you will say that when clock is comes here, this NAND gate becomes shows zero outputs, but with this NAND gate, due to the this input is giving high input, that's why it gives high. When high comes here, this input becomes low and output gives a high. You can see here. Okay, this output will be high in any case. Why becomes any case? In one case the clock becomes high, in the other case it becomes high. That's why it always giving high. It, when the both inputs of this NAND gate is high, and it's giving low at the output. Similarly, this NAND gate, why giving all times high? Because one of the input of this NAND gate is always low. That's why it's always giving a high. So it doesn't matter that this input becomes high or low, it always gives high at the output. So that's why it's directly depending upon the input signals. Now in that case, you can see that this output becomes high for all the time, and that's why it's also make this NAND gates, you can say, off. And now this NAND gate is working, and this NAND gate is providing the both inputs as high. Why both inputs are working as high? Because these inputs have to make low for all the time, and this input will be once high or once low. That's why the NAND gate will always be high at the output. You can easily understand here. Let me do some quick input outputs high or low. You can see here that either if I quickly change the inputs, the output will be high for the long time. But if I lower the output for some time, input for some time, and then make it high, then you can see the waveform here. I hope you understand the working principle of edge trigger D flip flop, sorry to say, and you can easily understand how we can draw the circuitry of the edge triggered D flip flop. Thank you so much for watching the video. Please subscribe the channel and hit the bell icon.